Alright, what's up class? My name is Dejour Boyd. I'm going to show you guys how to prove identities. First of all, what you need to know to do these questions, you need to know the reciprocal, quotient, and Pythagorean identities. Reciprocal would be cosecant theta would be 1 over sine, secant would be 1 over cosine, and tangent would be 1 over tangent. Over here, we got the quotient. It'll be tangent equals sine over cosine. Cotangent equals cosine over sine. And for the Pythagorean ones, we have sine squared theta times cosine equals 1. Tangent squared plus 1 equals secant squared. 1 plus cotangent theta equals cosecant squared theta. Sine squared theta equals 1 minus cosine squared theta. Tangent squared theta equals secant squared theta minus 1. Cotangent squared theta equals cosecant minus 1. Cosecant squared theta equals 1 minus sine squared theta. 1 equals secant squared theta minus tangent squared theta. And we have 1 equals cosecant squared theta minus cotangent squared theta. And then, okay, so we're going to move on to the first example. And this is an easy example right here. We have cosecant theta times cosine theta equals cotangent theta, and we need to prove this. So first of all, you're going to use the reciprocal identity for cosecant, which is 1 over sine, as we've seen over here. And then you're going to multiply 1 over sine times cosine over 1. And once you multiply it, you'll get cosine theta over sine theta, which equals cotangent. And using the quotient identity for this part, you get cotangent theta equals cotangent theta. And then, easy. And you use the box to show that it's been proven. On to the next one. This question is more of a medium one. You have secant theta minus cosine theta equals sine theta times tangent theta. First of all, you're going to use the reciprocal identity for secant theta, and you get 1 over cosine minus cosine over 1. And you cannot cancel them out because there's a minus between them. So then you're going to have to do common denominator, and you have to multiply this side by cosine to get cosine as a denominator. And once you get it, you'll have 1 on this side. You have 1 minus cosine squared theta over cosine once you put them together. Then you're going to use Pythagorean theorem the Pythagorean identity for the top part, which gives you sine squared theta over cosine. Then what you want to do is you want to work on the second half to make it equal. So you'll use the quotient identity that gives you sine over cosine times sine over 1. And then once you simplify it, you'll have sine squared theta over cosine, which is equal to sine squared theta over cosine. And that's the proof. Now to the more difficult one. More difficult question over here. Alright, we have to prove secant theta over sine theta minus sine theta over cosine theta equals cotangent theta. First of all, you want to use the reciprocal identity for secant, which is 1 over cosine, and then plug everything in, and then you want to get common denominators. So this side you need cosine, and for this side you need sine. So you'll multiply this side by cosine, the top by cosine, and the bottom. This side by sine, the top and bottom. After you simplify it all, you get 1 minus sine squared theta over cosine and sine. That's after you combine them all, after you did your multiplication. Then you're going to use the Pythagorean identity for the top part, 1 minus sine squared theta. You get cosine squared theta over cosine times sine. And then you're going to cross out the squared with the bottom, which will give you cosine over sine. Use the quotient identity, and you get cotangent equals cotangent. And that's how you solve proving identities. Alright, thanks, man.
No problem. Yeah.